Hello, and welcome to Transformations Café, where we're serving light as bold as love. I'm your host, Ken Marks. Transformations Café is brought to you by the Institute for Global Transformation. We're a nonprofit, all-volunteer organization. Our vision is a world working together to utilize the power, love, and wisdom of higher consciousness to benefit humanity and the planet. Our mission is to support transformations in consciousness and in the way humanity interacts with one another so as to bring about positive change in the world individually and collectively. We invite you to visit us at our website, theglobaltransformation.org. If you would like to become part of our community formally, there are join buttons at the top of each page of the website. If you would like to support our work, including programs like this one, there's also a donate button at the top of each page that will take you straight through to PayPal. This program is being recorded and will be published on IFTT's YouTube channel. We have a good live audience with us tonight. Just for those of you who are joining us live, this program is not just an interview, but it is a conversation and the audience is invited to participate. If you do, we will accept this as your implied consent to appear in the publication. We also invite you to, and really encourage you to please subscribe to our YouTube channel. That will allow us to provide even more features for our audience, the more subscribers we get. So please, if you haven't already, subscribe to our channel and then hit that bell icon, which will notify you whenever we do publish new content. For those with us today, I do invite you to please participate and do that in one of two ways so I don't miss you. Both will involve the chat. If you would like to come on camera and ask your question directly of our guest, please type the letter Q, and that will be your indication to me that you would like to come on camera. Otherwise, you can simply type your question in the chat, and we'll get to as many of those as we can. So on today's program, we're going to continue our exploration and conversations about the ageless wisdom and how it shows up in our everyday lives. One of these ways is that there seems to be an increasing awareness of relationships between spirituality and science. From what I can tell, physics and quantum sciences are the fields of science that seem to have the closest relationship to spirituality. But in most of my experience in conversations about the quantum sciences, they're with people in the spiritual community and not actually quantum scientists. So I was wondering, what do quantum physicists think about spirituality and the relationships between science and spirituality? Well, as you might have gathered by now, today we have the great fortune of being able to talk with a quantum physicist, and we're going to explore these questions and more with Dr. Erik Deumens. I'm going to read a brief bio, and then we will begin our conversation. Erik Deumens grew up in Antwerpen, Belgium, and studied physics and mathematics at the University of Antwerp. He has been a student of Hatha Yoga since he was 17, following the teachings of Iyengar. He studied philosophical and religious texts on world religions, including the Yoga Sutras of Patanjali, for which he learned Sanskrit. That led to a practice of Ashtanga Yoga until today. After receiving his PhD in computational nuclear physics, he moved to Florida in 1985 to study at the Quantum Theory Project at the University of Florida, or UF, in Gainesville, Florida. He ended up working there several decades, building computer models of chemical reactions. Since 2011, he has been the director of the Department of UF Information Technology Research Computing, which supports all high-performance research computing activities in research and education on UF's supercomputer, which has to have the name Gator in it, so it's called the HiPerGator. Since 1976, when he first learned about quantum mechanics from the Feynman Lectures, he has been on a quest to understand the foundations and interpretation of quantum mechanics. He is still working on that today. I want to add that I've had the pleasure of meeting Erik on several occasions, And we had a very stimulating and lengthy conversation a couple of months ago, which helped me not only to get to know him better, but also shape the conversation for today's program. And I will tell you, he is indeed a gentleman and a scholar. So with that, welcome, Erik, to the Transformations Café.
Thank you. Thank you.
So I thought what we would begin with is you shared with me, and maybe you can kind of give a similar summary of your background and how you kind of came to have both science and spirituality featuring prominently in your life.
Yeah, so actually I started as a young kid, 9, 10 years old. I was just fascinated by space flight. I grew up in of course, the Apollo program. I was watching that avidly, and I read all these science fiction books. And one of my dreams was to go one day and travel to the Andromeda galaxy, which is 2 million light years away. And then I was reading this book about astronomy and the wonders of the universe, which of course fascinated me even more to go do this travel. But they mentioned the name of this guy called Einstein, who had proven that you could not go faster than the speed of light. Now, that was a big problem for me, because if I wanted to travel to the Andromeda galaxy and it would take 2 million light years at the speed of light and I couldn't go any faster, that was not something that I would ever be able to do. So I, as a 12-year-old kid, made the decision I was going to prove this Einstein guy wrong. And so I went to the university and I studied physics and mathematics, and the university had a very good program, so I really got a good education there. And unfortunately, after studying the theory of relativity, which has as a part of it that the speed of light is this limit, I had to admit that Einstein was right. You know, that he was right.
I hate when that happens.
But yeah, exactly. So then that was in the first couple of years of my college study. Then I came in touch with quantum mechanics through the Feynman Lectures. And somehow I had learned all the beautiful mathematics and physics of Newtonian mechanics and special theory of relativity, general relativity. And they were all so beautiful, and the details were all worked out, and you could just bite yourself into it and get to the bottom and get the answers. But then quantum mechanics had this thing that there was some beautiful mathematics associated with it, but then the way people talk about quantum mechanics has this weird vagueness. Like sometimes it's a particle, sometimes it's a wave, and the mathematics has sort of a disconnect from the way people talked about it. And I found that very frustrating. And then I also learned that many other people found that very frustrating. And that's where I sort of so I couldn't let go. And so since that time in 76, I was going to work on quantum mechanics and try to figure out how that really works. And so I used my entire career to study the detailed chemical reactions and how quantum mechanics works by following the mathematics and using the implementation of these complicated mathematical formulas on computers, because you cannot do it on paper, to really get a very deep understanding of how quantum mechanics really works and describes nature, and then how it sort of is talked about by other people. And I could understand why they talk about it that way, but I find it very confusing. And the problem is that when you have popular books talking about quantum mechanics, they use the way people talk about it, and they leave this fuzziness open, which is kind of exciting because it sounds like you're talking about a magic trick like Roy and Siegfried in Las Vegas, right? And it sort of has this allure but it's not really the way scientists who are properly trained in quantum mechanics and who use quantum mechanics in the lab to make all these wonderful things that we now have, computers and whatever. it's not exactly the same. So there's that dichotomy. And so that's what I've been working on all the time. And since 2004, which is now 20 years ago, actually, I recently read one of my notebooks, and my first notebook was in June of 2004. I've been working on like really getting to the bottom of this, and I made some really good progress, which is some of it is already published and more is going to be published. So I think I can make some contribution there in clarifying how people should talk about quantum mechanics so that there's no more confusion. But that's why I have a very strong opinion about how you should talk about quantum mechanics.
Which is exactly why we're delighted to have you here. And also then, do you want to touch a little bit then on how also you got introduced to things that might be considered spirituality or
Yes, yeah. So that happened in parallel. So I went to college, and during my college years and my graduate studies, I also got into the philosophy. I was raised as a Catholic, but very soon, and I was an altar boy, but also around the age of 12, I came to the conclusion that these people didn't have answers. Like the Bible is not enough. I mean, it's too vague. It's sort of like a popular magazine. You cannot dig deeper and get to the truth. So I started to read all the other things, Islam, Hinduism, and finally ended up with yoga scriptures and the Upanishads and the Bhagavad Gita, and I studied that very deeply, and I practiced, and I read all kinds of things, and I kept looking, and that was a search in parallel where I sort of tried to figure out, and I also constantly wanted to figure out, well, how does it connect to physics? Because that was what I know really well, and I wanted to know this spiritual world equally well, and I think I have a pretty good knowledge about it. I wouldn't call myself a guru in any way, but I'm definitely a scholar who knows about spirituality and what people think and what people have said. I've read and I know what lots of people said, and I can, therefore I also have these opinions that I think the way some of the spiritual leaders talk about stuff doesn't hold water. And so that's one of the things that we'll address today, I guess.
Yeah, I think your credentials in both of these major areas of your interests and study are impeccable. I'm guessing if we ask for a show of hands, how many others taught themselves Sanskrit? Probably not many in this crowd or others. So it's certainly impressive the energy that you bring to things. And something else that impressed me about you was that you accept and enjoy the challenges of these rigorous studies so much, including not just assuming, since the name was Einstein, that they had to be right, but you made them prove it to you in your own way. So I think that's part of what has yielded such a marvelous career and life that really, again, enjoying getting to know you more. I thought what we also might want to do at this outset, since there are terms that are used, and I find myself using one because I don't know enough about what the terms mean. So I've created this catch-all for talking about quantum things, quantum studies, and I just call it the quantum sciences. But I know often we hear references to either quantum physics or quantum mechanics. Can you tell us just in a few words what the definitions of those two things are and maybe how they relate?
Yeah, and actually quantum sciences and quantum physics is a lot in the news right now because in the last decade, there's a lot of effort and a lot of funding by governments and by private companies to build quantum computers. And so there's a lot of activity on quantum science. So what you should think about is that quantum physics and quantum science are the phenomena that really show the quantum behavior of the world. And the way you should think of this is when we started to learn about the way the world works, we started with what is now known as classical physics. Newton was the one who made the big first breakthrough. by describing the motion of the planets with this universal law of gravity and his law of force and acceleration. And then we had more classical physics theories that were developed, and what is special about classical physics is that the concepts that you use to describe what you observe in experiments and the concepts that are used in the mathematical theory to describe those in great detail are the same. So that is why when we talk about how do we get a spacecraft to the moon and back, or how do we get the Weber telescope, we put that there is a very special place where something can sit forever, which is where we put the Weber telescope. It sits there in this special point in space, and we can very accurately calculate that, and we can make sure that it goes there and it sits there, and it now is doing these beautiful things. What people discovered in the beginning of the 20th century is that description of physics is not perfectly accurate. It is good at the level of our normal everyday life, but when you start looking deeper, it doesn't work. You need a better theory. There are new phenomena that appear that are not describable by this older theory. And those are the quantum phenomena, or that's quantum physics, and quantum science deals with them. And so you do all these experiments and you find these quantum phenomena. And then you have to come up with a theory. And the theory that was invented in the beginning in 1926, so we're actually next year has been declared by the United Nations as the year of quantum mechanics, because it's 100 years old.
Yeah.
And that is when quantum mechanics was invented, and that is the theory that describes all these phenomena. And we know that that theory is correct because we've used it for the last 100 years to develop all these fantastic things that we now use for granted in everyday life, like computers and cell phones and all these things. And that's done by the theory behind that is quantum mechanics, and all the phenomena associated with it are quantum physics.
Okay, and I just want to make sure that we're talking about the same thing. You're referring to one of the space telescopes. Is that the James Webb?
The James Webb, yep, James
Yeah,
Webb
okay.
telescope, yep.
Which is also full of all sorts of fascinating, wonderful things in the news, but also might be part of what we're kind of talking about, or we'll get to this evening, about how some things that are discovered are then portrayed in mass media or YouTube media, and there's some liberties taken perhaps in the way that they're spoken about.
So there is sort of a very good distinction that you can make, and that is then when people read in the mass media and in the popular press and in the popularizing books about astronomy and astrophysics, you get a very accurate picture of what the scientists really do. Like the Weber telescope tells you, this is a picture of this galaxy. The galaxy is this far away. Stars are formed. You can see how they are formed and all these things. There's a very accurate description. When people talk about quantum phenomena, then there are these weird things like entanglement and weird particle wave duality. Then people have to come up with some other words that are not really one-to-one mapping with the mathematics that the physicists and the scientists use to do all these wonderful things of making these machines, and the way they talk about it, because there is no good way that people have agreed upon on how to talk about it. And that's where the confusion comes. And then they make statements that to somebody who just reads it might say, oh, that sounds the same thing as what I'm experiencing or what I think is happening. And then they sort of grasp onto that, but it's not, if you would dig deeper into it, you will find that actually it's not the same. And we can get into that.
Yeah, I think we should. I've got a long list of notes that I shared with you earlier, and we could go into a lot of it, but I think in one sense, maybe getting to some of the meat of what I think is of interest to this audience is that there have been an increasing number of references to quantum phenomena, like the one you just mentioned, entanglement. I think it would be fun to talk about the double slit experiment too, and talk about how there's almost become kind of common references, at least in some avenues, that talk about these things, and then they're used to, in some way, almost prove or validate some things that are talked about in various texts and scriptures and traditions, and are found in various presentations of the Ageless Wisdom. And they may certainly have that relationship, but I think it's great to have a better understanding and really know what it is that we're referring to, and not just assume, since we read it or heard it somewhere, that, oh, it must be so. And I will say, for our audience sake, that first time I met Erik, I brought that double slit experiment up, and he said, well, people talk about waves and particles, but that's not really it. And I thought, uh-oh, is he going to blow up my whole understanding that here's this beautiful scientific explanation for all of the things related to consciousness, spirituality, and certainly phenomena that I had either learned of or experienced directly. And I'm somewhat relieved, I guess, and pleased to say that when we talked further, you didn't blow it all up, but you specified how it should be talked about, maybe more carefully and more accurately. And so if we can get into that, I think I'll jump to this idea of, for those who may not be familiar with the double slit experiment, I'll give a brief synopsis, and then Erik, you can correct me. But basically, there was an idea of trying to see what happens when individual photons of light would be shown through an apparatus that had two slits in it. And the idea was that there was a detector that would pick up where the photons landed after they went through these slits. And the assumption was that they would simply show up as individual dots on the detector, basically, right? And then what was actually found was that under certain circumstances, instead of showing up as just a dot that hit the detector where one might expect, they actually form more of a wave pattern on the detector. And the understanding, or at least the way it's talked about, is that whether the experiment was being observed or not seemed to have an influence on the results that were found. And my understanding, at least, of why this could be of interest to people that are into more of the esoterics or think about things like a quantum field, or there's a wonderful gentleman that we've had the chance to interview and is very well known, Ervin Laszlo, who talks about the Akashic field. But basically, again, to my understanding, these are references to fields that hold all of the possibilities of the universe, and that interactions with that field then create probabilities that can then manifest into denser forms, like thoughts or actual physical forms and structures. And that the idea of this being a particle or a wave shows that, oh, well, here's a quantum science correlate to the idea that there is this field of all possibilities. So that's my kind of basic understanding of what this is about and why it might be of interest to people who are also interested in things like a quantum or Akashic field. But you told me when we spoke a couple of months ago that, yeah, not exactly right. Not exactly right. So if you would, please enlighten me again, and maybe others who share my understanding.
Yeah, so let me maybe clarify a little bit more about why the double slit experiment is so confusing. So when you send light through what is a double slit. It's basically a black plate that has two openings, parallel lines, and the light comes through, and on the other side, instead of just getting a lit line for the left slit and another lit line for the right slit, you get a pattern where there is the most intensity in between, where would be the hit of the left and the right, and then there is a dark band, and then there's another light band, another dark band. It's called a diffraction pattern. When you use a wave theory, then that all comes out natural. You can do this in water waves, and you can see these diffraction patterns because the waves just build up, and it's all very clear. Then when people started to do this with light, they discovered that if you lower the intensity of that light beam to the point where there is only a small amount of light and you need a very sensitive detector, then you get nothing but individual flashes on your detector. And that basically made people think, oh, light is not a wave. It is made up of little particles. But the problem is that these particles are still, when you keep shining that very low intensity beam for a long time, these dots keep randomly appearing on that screen, but they slowly build up that wave pattern. So people had the assumption, well, if they're particles, then each particle either goes through one hole or it goes through the other hole. And the only thing you can have is you're going to have a light place behind one of the slits and another one. You can't have these patterns. And you can even test this by closing one of the two slits, and then you really see just a one-line thing. And if you open them, then all of a sudden, these particles have this different pattern. So the conclusion that the scientists made is, well, that means you have this. We see a particle when we detect it, so we're going to assume that it is a particle. But how can that particle go through one slit and know about the existence of the other slit so that it has to make that wave pattern? That is the conundrum of quantum mechanics. So now you have this thing that somehow these particles, which we detect, so we believe there are particles, have to know about this other stuff. So there's some magical thing going on, and that is the canon explanation is, well, that's the wave function. But then people are arguing, well, what is this wave function? Is this wave function a physical wave? Well, no, it's not a physical wave, because if it was a physical wave, then we would see a continuous growing of that pattern, not random spots. So that's where the whole problem comes. And the way Bohr in 1925 resolved this issue by basically bullying everybody else to shut up and just listen the way he said it was, by saying, well, there are some things in physics that you cannot ask. You just cannot ask where the particle goes. The particle is only meaningful at the moment it's detected, and you cannot ask where it is moving around from when it gets created, going through these two holes. So you cannot figure out where it goes through. And that is basically so that the language of, well, you cannot know how Siegfried and Roy do their magic tricks. That's professional secret. They're not going to tell you, and you are never supposed to know. And the result is then that is now the standard way people talk about quantum mechanics. And then people can sort of say, oh, if that's the way it is, then I can interpret that in some other way. And that is how spiritual people can now say, well, there is that field, and the field has this possibility of the particle just gets created. Because if you can't ask where the particle is while it goes through the slits, well, then it just gets created the moment you detect it or something, and that's how it allows you to talk about it in these fuzzy ways. And scientists cannot give you an explanation of how you should better talk about it, and so that's the state of the art today, and that creates this confusion of allowing people to talk about things that are sort of inherently fuzzy, and that's why quantum mechanics is both fascinating and confusing.
I've come up with this term I call the perception dichotomy. And it seems like the issue that a lot of these black and white thinkers, like scientists often are, is they want definite answers. Is it a particle or a wave? They do an experiment to prove it's a particle. It proves it's a particle. They do an experiment to prove it's a wave. It's a wave. So why can't they pivot and understand it's both? Now, Diane Collins wrote a book that describes this phenomena spiritually. We have to learn to perceive both things at the same time. That's the perception dichotomy. So, yeah, it literally is both, right?
Well,
at different times.
In life, there are spiritual aspects where it is perfectly meaningful and true that things can be both. But physics is physics. Everybody agrees on physics, and you cannot have it both ways.
Well, then how do you explain the dichotomy of the particle wave? Is it a particle?
Well, people
wave?
have been
No,
arguing. People have been arguing about that for 100 years, and the thing that I'm advocating is, well, it is not really a particle, a classical particle. It is not really a classical field. It is, when you look at the mathematics that was invented in 1926 and 2025. It is what is called a quantum field, which has very different mathematics that is very more complicated, and that we don't bother explaining to people because it's too hard to explain in a conversation like this one. And that is what you need to work with to get to the phenomena that you see, that quantum field sometimes in a detector shows up as a particle, and it has at the same time wave-like things.
Right. Now, a particle, I understand, is no longer really a particle, an individual particle. It's considered a packet of energy, correct?
Well, actually, it isn't that either. It is just the way it gets detected. It gets detected as a local effect, and so people draw the conclusion that it's a particle. But it's actually no proof that it's a particle. In classical physics, if you saw something that was locally detected, then you could draw the conclusion that it was a particle. In quantum mechanics, that's not true. There are other mechanisms by which you can have a local effect that was not caused by a particle.
And earlier you talked about you can't get faster than the speed of light. I heard that there's a theoretical particle that supposedly its minimum speed is the speed of light, a tachyon. Have they done any more research into that?
There's lots of people doing research in that, but so far there's been no experimental evidence that it exists.
Okay, next question I feel is very germane to oneness and what I call quantum consciousness. First question is, when you're talking about the particle, seems like it'll choose the left slit or the right slit. So does that mean that there's a form of consciousness in the particles and the wave?
Yeah, so this is where people let their fantasy and their imagination go wild. So they draw this conclusion from what they see on the detector screen, and then they say, well, what we saw on the screen looks like a particle hit it. Well, if it is a particle, and this is already an assumption, then the particle probably was already a particle while it was traveling to the screen. And then you say, well, if it was traveling close to the screen, then maybe it was also a particle traveling when it went through the slit. And then you start thinking about it. Well, what happened? Well, all of that is wrong. We know that you have to do much more complicated mathematics to figure out what happens when it goes through, and it's not a particle and it's not a wave. It never is a particle and it's never a wave.
it seems like there's more conclusions that can be brought to the science and quantum physics through spirituality. It seems like when you study Buddhism, Hinduism, Taoism, Kabbalah, the ancient wisdom teachings concluded that all is one. And now we have almost like quantum physics is proving that based on quantum entanglement. You've got two particles that when they separate, they're communicating with each other light years apart instantaneously. So that's faster than light communication. How do you explain that?
Well, those are ways that people have accustomed themselves to talk about these experiments. And I think that is an unwarranted conclusion. It's not the right way to deal with physics.
Well, quantum entanglement has been scientifically proven through experimentation that I read about.
Oh yeah. But that's when you're describing the effect instead of, it doesn't give you an explanation of why it's that. So when you come up with an explanation of saying, oh, it's the same as spirituality, then you're making a conclusion for which you have no experimental evidence.
Okay, final question. If quantum entanglement exists between particular particles that separate like that, and the Big Bang theory is correct, and I've heard that there's some theories that debate whether it's correct or not. So my understanding of the Big Bang is everything in the universe existed as a infinitely small, infinitely small particle at one point, and now at that point, everything in the universe was quantumly entangled in that particle. And when the Big Bang happened and everything separated, they're all still connected. So all is one. That's a spiritual fact.
Well, so the way, so this brings us to a very interesting sort of point, and that is that the way our current culture talks about science and the world is what Mona Sobhani calls scientific materialism. You make the assumption that the foundation of the world is physics. And everything that we see, consciousness, spirituality, is an emerging thing that comes out of this physics. And that's why people are using this reductionist thinking of trying to reduce everything to what happens at the physics level. And within that thinking, it makes sense to say, well, we know these spiritual things. Let's see if we can find some physics thing that could support that. Well, that view is upside down. It is not true that spirituality and consciousness comes from physics. It's the other way around. Physics is something that happens inside consciousness. Consciousness is first. Consciousness is everything. And physics comes from that. But then the physics is just a structure. You don't have to explain that, and this quantum entanglement is just an aberration of how you talk about spirituality and what consciousness can do and accomplish. Physics is just something that emerges from consciousness.
Now, there are lots of parallels. Fritjof Capra, I'm sure you're familiar with him. He wrote The Tao of Physics. And in that book, he delineates the parallels between quantum physics and spirituality based on all those wisdom teachings I mentioned earlier.
That's right. That's right. But he is a scientific materialist. He tries to reduce everything to physics. So I think he has the world upside down. When you look at what people testify from what they have seen of the spiritual world, like from near-death experiences, then you know that they have seen the world and it works different from what you would get if you try to reduce everything in the spiritual world to just the mechanics of physics. Let me give you an example. Suppose that we are looking at a city and we are observing all the cars. you could come up with an observation of the behavior of these cars. You could discover that the cars drive in these pathways that are streets, and they have weird sort of rituals at certain intersections. There are these lights, red lights and green lights, and there are kinds of rules for when you turn left, and there are when you turn right, and there are these other things. And so at some point, you can describe and come up with a theory that's pretty good about how does traffic flow through the city. But then when you start looking more closely, you all of a sudden there's some really weird behavior. Some cars do really weird stuff. They don't follow the normal, just the traffic laws. And then you can try to find, well, why is that? Well, and the reason we know is that cars are not the way we might have in the future self-driving cars. There are people inside, and these people have opinions and emotions, and they do all kinds of weird things, and they're not described by these laws that I've been developing about traffic and cars. You see what I'm saying? So physics is sort of like this world and of all the cars, but then our spirit inside has the ability to do things that don't obey these laws, because there's a different thing that is more fundamental than the level of description of the city as just a collection of cars.
Well, thanks, Michael, for the questions. Erik, I really am delighted that the conversation has taken this turn, because I think ultimately that's one of the takeaways that I was hoping you'd be able to share today, that consciousness is primary, and then the physics that we're discovering may help to provide some scientific frame for spiritual things that we study and or experience or witness. Those scientific explanations are just a different language to help talk about it, but they're not the proof or the cause of them. That it's kind of the other way around. Debbie, I think you were next in the queue. If you want to unmute, thanks.
You kind of already answered my one question, and in fairness, I've known you for a long time, and we've had several discussions, so I'm kind of aware of some of this. But as you said so eloquently, everything arises from within consciousness, and physics is just a concept or a paradigm that we use to try to make sense of some things, but it's contained within something much larger called consciousness. But can physics or science in any way, shape, or form help us to prove the existence of consciousness or boundlessness or stillness, or is it not a useful tool for proving it? So and then the second part of that question is, could you also elaborate a little bit on your journey with grief and how if it has informed your understanding of the relationship between science and consciousness, and if so, in what way? So
Yeah,
two-part question.
so this is where we need to make a distinction maybe between science as it is currently talked about and accepted, and the scientific method. So when you really look at the spiritual path that everybody is following, as we all know, there are many paths. Everybody has their own path, and there are some teachers that teach something that you can help, then you have to adjust it to yourself, right? And many of us have taught that because we tried something and it didn't quite work. We tried something else and it didn't quite work, and we tried something else, and then somehow the combination of all the things that we tried, we allowed to make something that worked for us, and we made some progress. That is actually the scientific method. And what is important about physics is the Greeks did a lot of physics, but they basically sat in their pools or in their saunas, and they talked about philosophical principles. It wasn't until people started to actually say, okay, you say it's like this, let's go to the lab and do the experiment. Get the experience, right? It's one thing to talk about what somebody else says they saw, and then go and reproduce it yourself. And I think that is on every spiritual path, is you have to at some point get your own experience. If you just believe what your teacher is saying, you should feel this, at some point you sort of, your brain will believe and convince yourself, I believe it, I can see it, I can feel it, you know, but it's not real. You know, you're just making it up. You just convinced yourself, you indoctrinated yourself until you really feel it. And then after a long time, and many of the people present here have this experience themselves, all of a sudden you sort of say, wow, I've heard talking about this, but I never knew it was like this. That's the scientific method. You have to have the experience. Once you have the experience, now when you talk about something, you actually know what you're talking about. Otherwise, you're just talking about what other people say, and it's a word that doesn't mean anything. So the scientific method can be used to the spiritual path, and that's what you have to do. You just basically do all the physics. You do your experiments, and lots of people have done these experiments. You can go read about it in books. You can do some experiments yourself, but right now these experiments are so well documented, you don't even have to do them yourself to convince yourself. And most of us have a lot of enough experience to sort of know that this is the case. But on the spiritual path, I think we're all novices. And we have to get some experience before we can move forward. And so this is where spirituality is just a continuation. Like I was saying, in the beginning of the 20th century, people discovered that the classical theories were not enough to explain some of the experiments they were doing, because they invented some new technology and they could see a little bit better, more accurate. The microscopes were better and they got some new things. And that's what we have to do spiritually. Now we have the physics world. We know how the physics works. There's a theory about it. We know how to deal with it. And spiritually, you can go deeper and get that experience and then learn from it and do your next thing, which is why we're here, to learn all that stuff. So that's where, yes, science and physics and spirituality, they're just one range of continuum, and you're just going to go deeper to more subtle and more complicated things.
Debbie, you had a second part of your question too.
Yeah, I was just wondering if you could, if you feel like your journey with grief from the last several years has deepened or expanded your understanding of knowledge, either of science and the end of consciousness, or both. I thought you could talk.
Yeah, actually it was a big, I mean, so I've lived with my wife for 35 years, and until she died very unexpectedly, and she and I were really good friends, and she always was very much supportive of all my crazy physics things, and also my spiritual evolution. And one of the things that she got me to follow one more different path to do my yoga and to increase my spiritual awareness. In 2009, she said, hey, maybe this will work for you. So since 2009, I was doing these new exercises, and I just kept working. And the teacher basically said, you know, if you do these things deliberately and you practice every day, you're going to see difference in 3 years. So, you know, I started in 2009. I remember it was somewhere around Thanksgiving, and 3 years later, I was like, I don't see any difference. You know, I was just trying really hard. I did an hour in the morning and an hour in the evening. I really worked really hard. And so then my wife died in October of 21. And, you know, that was 12 years after I started this, and I really hadn't made that much progress. I, you know, worked hard at it, but then since then there was sort of I tried a different approach with her guidance, with her spirit still giving me these weird ideas. There were some things that all of a sudden popped in my head. I said, that's not my thought, but I would recognize it as Liz's thought. You know, so there was something that I did that I normally would not have done, but she told me to do it, and I did it. And then it wasn't until the retreat, at Lisa's retreat last November, and also not just the retreat, but also the trip with Jacqueline to it, that really triggered several things. And then in the months since, I've made more progress than in the 10 years before that. So I really needed to have a strong whack on the head to be, you know, steered in a different direction, and some guidance from outside of myself.
Thank you, Debbie, and thank you, Erik. I think either another part of this program and a conversation with you again, or just some time between the two of us sharing our experiences of grief and how those have helped mold our ongoing journeys on the path and in life would be fascinating to share. So yeah, I don't want to distract the rest of the conversation.
Diane has a question.
She does, and I just want to say I appreciate you sharing that personal information with us too, Erik. So yes, Diane.
Okay, thank you. Thank you. Very enjoyable conversation, Erik and everyone. Okay, when you say physics, and I've had some kind of logical thought about this, so I want to check it out with you, Erik. That first of all, physics, whether it's classical physics or quantum physics, would you say that physics studies or investigates, explores the manifest aspect of what we would call physical reality? Is that how you would characterize?
Yes, yes.
Okay.
Actually, one way I would like to think of it is that the study of physics is the analogy of studying the buildings that we live in. And then when you want to go beyond that, you talk about, well, what do people inside buildings? And that's the more interesting part. Physics is just the environment that you work in.
Okay. So we're talking about material, right? Scientific materialism or so, and then the material. So do you consider energy, and I realize it's a lot of different states of energy, but energy as an aspect of the material world, or what Einstein E = mc squared, but energy and matter, physical matter, are convertible. Is that
so? This is a very, very good question, actually. And that the problem is that we have the word energy, and it means two different things. When you are talking about energy, physicists have a very specific meaning of what is energy. It is that thing that's associated with motion of cars and arms and legs. So let me draw another little analogy. Suppose you want to do exercise. You're going to run. And in order to do that, you are using energy. Your muscles move, you're burning all these calories, your muscles move, and it's all controlled by the laws of physics. But now let's go back to an hour before you do your exercise. You're lying in bed and you wake up. And you wake up and you feel really good. You feel well rested, and your body is full of energy. The energy you feel when you just want to get up and get going with the day, and then you're going to do your running. The energy that you feel at that time is what the Chinese and others call your qi. And that is not the physical energy that you're going to use when you're running. Now, when you have that good qi feeling, you will find that it's very easy to get your muscles going and you feel positive. Now, there could be another day, like the day before. You also wake up in the morning and you have a hangover from the night before and your body feels all heavy, then you have no chi whatsoever. And you say, I want to go run, I have to go run, and you actually go run, but you feel that everything is very sluggish. And that is where you as a person experience the two kinds of energy. The physical energy of motion and the chi, which is more your nervous energy and your life energy and your spiritual energy. And they're very different. Now, we use the words and we use them often interchangeably, but to try and say the two are the same or they're in some connected, no, they're very different. And in principle, we should use different words for them if we were really precise people, but we're not precise people.
Okay, which brings me to my question. Okay, that's good. Thank you. That because I had this thought, well, actually I wrote it, time for a new science, because if physics is studying what we consider to be the material aspect of reality, right? And if the material aspect of reality, as you said earlier, I think, and I agree, that not agree, but kind of know, that consciousness is the primacy, and from that comes the material. So I actually have this two-part question. So one is just related to a practical of science, that it seems like it's time for a new science, because if you're trying to study with what the science that has been developed to study material or matter, or I don't know, you could be more precise with the terminology than I can as a non-scientist, that if physics is designed to study the material world, and yet consciousness, or what people consider, you use the word spiritual, whatever that subtlety is, Irvin Laszlo, the field, then would you say it's time for a new science? Because how can you apply a science that's designed to study the material world, and how do you apply that to the world, which, as you've been saying in various ways, that it doesn't fit there. So
but I wouldn't call it a new science, because we want to have the science that we have that does all the physics and chemistry. We want to keep that. We know it's right. What we need to extend it.
Yes.
We need to apply the scientific method to go beyond what we have been looking at before, and we have to give up this principle of scientific materialism, that you can reduce everything that is ever observable to the existing theories of physics and chemistry. You need to go beyond that. And actually, Mona Sobhani and Ken interviewed her. She has a wonderful book where she, against all her will, was slowly convinced that, yep, there is more to the world than what scientific materialism says it is. And that's exactly what you were pointing out. It's not that you need a new science, but we need to extend the scientific method beyond what it has been applied to today with an open mind.
Well, earlier yes. But earlier you said to make a distinction between science and the scientific method. So what you're saying, and I see this, that you could apply the scientific method, maybe, or an extension of, to the non-material aspect of reality. But it wouldn't be, when I say time for a new science, maybe it would be a new science. Okay, I don't want to get into
it would be an add-on to the science. It's not like you want to throw the old baby away. It's going to be, you're going to get a new baby. You're going to get them a sister.
You could get a new baby, but I think it would come from the same perspective that it wouldn't quite work out, which is probably why people are in such a dilemma about things that seem not in the ordinary logic. But let me just ask this one last thing, if it's okay, Ken, and everyone in it, that because much in the beginning of the conversation, and you were saying to us that in your study of Vedanta and, you know, that whole yogic tradition, let's just wrap it up like that, and Michael was asking about the question, like that you cannot, that it wasn't what they were saying, the wisdom masters, I call them, or the, you know, the science of consciousness of those traditions, but that they didn't match up with what quantum physics is proving. So could you just say something more about that? How does it not match up?
No, I'm not saying that it doesn't match up. It's saying that you have to remember that in those days, people didn't reveal their secrets. So all the scriptures are deliberately very vague. And it's only when you got to the master as a personal student that the master would reveal how you would actually do this and give you that experience that I was talking to you about. All of us have to have access to personal experience. And when you read all these scriptures, the only thing you get is what other people are saying. And if you don't have the experience and have no mechanism to actually get the experience, they're just words and you're going to make them up. And there's all kinds of people who have made up real words and they have led many people astray to do this. So it's just that they weren't clear enough. Whereas with the scientific method and the physics, there we go, we do the experiment, we get the experience, we make the theories, we make sure that they're consistent. If we find some new experience that doesn't fit with the theory, out the theory goes. And that's what we have to just keep doing. Right now, we're getting to the point where there is enough evidence on these spiritual and paranormal phenomena, and because the scientific community is so adverse to accepting that as reality, they all think it's just bogus. The people who do these experiments actually hold themselves to much higher standards than normal science. And so there's some really good evidence that we have data to extend and get to what you were saying would be the new science. So it's already has been going on for decades.
Yeah, I would say to that point, someone like Dean Radin and the scientists at the Institute of Noetic Sciences, they do hold themselves to a much higher standard, as you're saying, Eric, than I think might be expected elsewhere. So
yeah, because they have to convince the non-believers. I mean, everybody's so skeptical, they have to just make sure that there's absolutely no mistake or no question left in whatever they do as an experiment.
Again, as you're kind of saying, Eric, words and terms can get thrown around, but until you actually have optimally an experience, but at least a better understanding of what those terms mean, especially as they get more technical. So can you talk just a little bit about what actually is quantum entanglement?
So quantum entanglement is actually it's a standard technology and term in the field of statistics. And it's when you see you observe different phenomena and you detect that there is a correlation between them. But when you do normal statistics in the field of medicine, for instance, and you say, well, I do these, I look at all these people and I measure their health or their behavior or whatever, and then you start investigating, well, where do these people come from? Oh, they live in this state and they live close to a lake, or they go every day jogging or whatever, and you can find where the correlation comes from. And that is then a publication, in some medical journal is like, okay, we figured out why people who live near these lakes have this kind of thing, and people who live in the city have asthma attacks or whatever, right? So that's, you find these correlations. So what happens with quantum mechanics is, instead of talking about really complicated things like people living in cities and in villages and doing all kinds of complicated things, you're talking about these stupid, simple particles. And they can't do very much. And now you get this weird correlation. And you have nothing to try and come up with, why does that happen? And that's where people said, well, we found this correlation. There's no way that we can reduce this correlation to something else. So we just call it entanglement. And then we talk about entanglement, because we cannot explain it in terms of anything else. Whereas if it was about people, we would say, well, yeah, that's because this person, has a car, and this person has whatever, right? So there's a reason, and then entanglement is not mysterious. But for these particles, they are just particles. There's nothing complicated about them. They can just fly around, and now they have this weird correlation. And that's why it's entanglement. So now my answer to that is,
thank you.
Well, if you really follow the mathematics of quantum mechanics and quantum field theory, there's a lot of mathematics, and when you follow that mathematics, you actually can get an explanation. But that will be way too long to explain to this place, unfortunately. So I think there is a way, and I'm trying to convince the scientific community, and I just got some reviewer comments that this guy said, hey, this is a very plausible approach. You just need to provide more details. So I'm working on more details. And so.
But in the general idea of quantum entanglement, which was related to the awarding of a Nobel Prize a couple of years ago.
This year, actually last year, yeah.
Last year, okay. So, but what is the general idea? What are people referring to when they say quantum entanglement?
Okay, so quantum entanglement is, you take two particles and you create them close together, and one of them is there's some internal thing about quantum mechanical particles that makes it easy. They're sort of spinning like a spinning top. And when you create them, you can create them so that one is spinning to the right and the other one is spinning to the left. But you actually don't know in which direction one could be spinning up, and then the other one has to be spinning down. Or one could be spinning to the left, and then the other one has to spinning to the right, because they have to balance each other out. And so you create them, and then they travel away. And that pair is what is called an entangled pair. And now it turns out that they can travel as far as you can imagine, long time, light years, hundreds of kilometers, thousands of kilometers, they can travel very, very far. But then that if I measure one of them, and I measure that this one is pointing to the left, or to your left, then I know that the other one that is hundreds of thousands of kilometers away, if you go measure that one now, it'll find to the right. That is that correlation. That correlation is in there from where they were created. It gets carried along. But the problem is, you would typically think, well, when they were created, they actually picked, one was up and one was down, and they now travel, and then you measure it and you find it. But quantum mechanics doesn't work that way. When you measure it, you actually don't know whether it was up or down. So it was not the fact that they were up and down instead of left and right was not determined from the very beginning. It gets determined the moment this one person who measures it, and then instantaneously the other one is also in the same matching whether it's up and down or left and right. And that is where this instantaneous spooky action at a distance comes from, right? Because you cannot say that it happened at the beginning. You can prove that it didn't happen at the beginning, because then it would be easy. And then it's the same as I take a package and I send a red sock, and I know I'm going to tell Debbie and you, Ken, I'm going to send you a sock. And I send one red sock to you and one blue sock to Debbie, but I'm not telling you which one. But I did tell you that I did send a red and a blue sock. So once you open your package and you see there's a blue sock, you know that Debbie got a red sock, right? Because that's how I put the package in the mail. Well, for quantum entanglement, it doesn't work that way. It's sort of like, okay, I'm saying there is a red or a blue sock, but it's not clear which one goes where. It's only the moment you open it, that's when the sock decides what color it's going to be. That's what happens with quantum mechanics. And then instantaneously, when Debbie opens it, she's going to have the other color. That's the mystery of entanglement.
As far as another parallel I've noticed between spirituality and the wisdom teachings, which they say, I believe it's Buddhism or Hinduism, Maya, illusion. It's all an illusion. And the parallel in what they've discovered in quantum physics is there's more space than anything else. And when you talk about a particle, it's not really a solid thing, because the linear accelerators are bombarding tiny particles against each other to see what they're made of, and they find other subatomic particles and they analyze those, and they're mostly empty space too. So explain that if you can. It seems like obvious parallel.
Yeah, I mean, it's an obvious parallel in the description, but it does not help me in understand either the physics or the spirituality better. So I think it is nice to talk about at 4 o'clock tea hour, but it's not useful to really lead me on my spiritual path or to help me as a physicist to make better, more interesting things.
It seems like all is empty space, and our perception it seems to be solid because of the way we perceive with our limited physical senses, but in reality, or ultimate reality maybe, it's all just empty space and it's all an illusion.
Well, actually,
our senses.
I'm not going to contradict that, because the way I think of it is everything is just emerging into awareness and the boundless. And that means that it is sort of no more real than the virtual reality of a video game. There isn't, I mean, so if you want to say, well, it's nothing but space, sure, yeah. I mean, there's nothing real there. It's just a video game. Because it's all created for our spirits to learn, to provide them with an environment. And it's a really good video game in the sense that it has no glitches whatsoever. Like if you push on one piece that you think looks like a door, it's a solid door. You know, you're not going to go through the door, and so all the physical details are there, and that makes it like a perfect video game. But that's what it is, and that's where we are now, sharing that all of our spirits are sharing this information within time. And actually that's where the wonder of time comes in. Why do we need time? That is because our spirits are in the timeless, and that means everything happens at the same time. Well, if everything happens at the same time, you cannot understand anything. You're just sitting there feeling blissful. But if you want to understand something, like if I try to explain something to you, I have to slowly build it. Like I'm giving you an example, trying to make you look at something. And in order to do that, I need time to unravel it for you so that you can follow. And then in the end, you can say, oh, now I get it. And then once you get it, you the time can collapse and you know what I was talking about. But in order for me to convey it to you, I have to have time. And that's why we live in time. And we also need space to explain things. And that's how we learn. And that's why the physical world has all the properties that it has for us to learn.
It seems like linear time is also an illusion of the human experience.
Yes, it
Because
is.
all of time exists at the same time, but we have to live in an experience of linear time to experience things from one moment to the other.
Yeah, exactly.
And Erik, you mentioned when you and I had the chance to speak earlier, the completion of the thought that you're sharing with us now is that you talked about consciousness as source, essentially, and why is all this then happening? And it was consistent with what is found in explanations through the wisdom and other traditions. But if you're with me, you want to just finish that thought, because I think it's very important to share in terms of why do we experience time linearly and space the way that we do? And I'd love for you to share your thoughts on that.
Yeah, so somehow, for reasons unfathomable to me and us probably, but certainly to me, God as this awareness needs to learn. There's something that drives it to manifest and have this world that we live in, have this incarnation to learn, get the experience, get a lesson, and then, this one incarnation dies and we have to make another one until finally we all get it. And why we need to get it, I don't know, but that is sort of inherently part of awareness, I guess. I mean, in some ways you could sort of say, well, if you have awareness, everything is awareness, you have to be aware of something, and the ultimate goal is you have to be aware of why awareness is necessary, and then you're gonna do this, and so sort of makes sort of sense.
It's
Yeah.
all about curiosity, human curiosity, to know, understand the
Well, actually,
universe.
this would be divine curiosity. Our human curiosity is just the shadow of the divine curiosity of why we are incarnated.
What is the place of creativity in physics?
Well, it requires a lot of creativity to take various results and observations from experiments to then come up with more refined experiments to really ferret out the details and then come up with a theory of how it's all connected. So it requires a lot of creativity to do physics and do any of the sciences. And then they have the side effect that they make life better and more manageable and allow us to do more complicated things. Like with all this electronics that came from the discovery of quantum mechanics 100 years ago, we have managed to build these computers and the internet. And as a result, all of us and our kids, you can see it in our kids, they learn much faster this vast amount of information that's available in our world. It has side effects too, because as we know, social media has some devastating side effects on the depression of teenage people. And so we need to learn how to figure that out. So that's a challenge for us as a society. But at the same time, there's a lot of benefit too. And we need to figure that out. That'll require creativity in physics and beyond physics. But in order to get here, required a lot of creativity from a lot of people on how to build it and make it all work.
What to bring things to a practical level of what you should start to, you went in the direction. non-local communications, right, Eric? Anyway, quantum computing, what is the dilemma that it seems like it's taking a long time, relatively speaking, to actually come up with quantum computers? Or I don't know if there are any, or maybe quantum computers that work or work better or aren't, like a dense prototype. And like, what is the dilemma about it? And do you think that large language models or AGI will help resolve whatever the problem or the dilemma is? Like, will actually come up with the solution to the creation of quantum computers?
That's a very interesting question. So there are two hot topics in today. One is AI, and the other one is quantum computing. AI is a technology that people have been working on since the 60s and 70s. And finally, we have enough data and enough compute power to really make it to work at the scale that it needs to work to be effective and do something. So right now we have AI that's definitely growing. Quantum computers is another technology that is over 20 years old. And the reason it is so hard is because this thing that we're talking about, entanglement of quantum systems, is incredibly delicate. The reason our computers work is that although they are small, at the quantum level, you're still talking about billions of atoms making one transistor and having a little current flowing that makes it all makes very fast, and it looks microscopic to us, but it's not that small. For quantum computers, you're looking at a single atom or a single electron or a single photon, and that is very delicate. This whole entanglement is very delicate. So if somebody walks in the room and the vibration of you stepping on the floor can flip the qubit inside your quantum computer, and that's what makes it so hard to make it work. So it's going to take a while before we get there. We made tremendous progress, but it's going to be a little while. And it's not necessarily AI. AI will help, but it'll require some creativity, like people were saying, of physicists and engineers to make it work.
Right. Very interesting. Thank you.
Well, this has been an outstanding conversation. I have one other thing that might be kind of fun just to get your thoughts on, and then we can wrap up. I don't see any other questions in the chat. Thanks to everyone that did answer questions. It's been a great conversation, lots of interaction. There are other things that Erik, you and I talked about that kind of got more into spiritual phenomena or things that we hear about in a variety of consciousness circles or conversations. And one of those was the idea of soul groups, and that there are multiple incarnations, and that we may well kind of travel, if you will, between incarnations and in different incarnations with the same group of souls. And you said that made sense to you as a physicist. So I'm just wondering how you put those two things together.
Yeah, so as an individual, we all have our own notion of self and individual soul. So we make this extrapolation that our awareness is this unique spark. Again, it's a little bit like thinking of, well, we have one body and there's one soul in there, and it's the same as we see this spark on that experiment, and so we think it's a particle. Well, but that doesn't necessarily mean that we're really just a particle in awareness. If in awareness you're going to have an incarnation in one body, why not there be other sort of aligned awarenesses that are figuring out how are we going to do something together. We all know in our society already that if you have a team, you can get more stuff done than when it's a single person. And as a matter of fact, often like what we're doing now, right? So there are different people that have different questions and different answers. And together we learn something from each other. And at the end of the meeting, all of us are better off than we were an hour and a half ago. And I think it seems logical that the same thing would happen at this awareness level, where there's one soul that incarnates and there's a couple of other souls that somehow are in some ways connected by being physically together. And then they learn something in one life, and then they reincarnate, and you get the same people again together because they already are a little bit aligned. They get along and they know how to communicate in some mysterious way. And so they can get more done than if I would just be dumped as a single soul somewhere else with total strangers. And so we might consciously decide, okay, we're going to incarnate together because we need to learn this thing. Let's figure this out. And maybe there's a person who played the role of the father in one incarnation and the son in this other incarnation, and they had a really big fight, and the mother was sort of instigating the tension between the two, and now the three of them figured out, look, let's play the role a little different and figure out, you who were the wife and the mother in one role, now you're going to be the kid, and we're going to try to figure out how this interaction really works or something, you know. And
Erik, have you heard anything about the uncertainty principles proving free will?
oh yeah, I think that's really, again, one of those things that people love to talk about for 4 o'clock. Actually, maybe that's probably like 8 o'clock after you had a couple of beers, and it makes no longer sense. Yeah, it's just talk.
All right. Erik, is there anything else that you were hoping to discuss or share that we haven't covered?
Nothing comes to mind. I think it was a very interesting conversation.
Okay, great. Just wanted to make sure that it was a great conversation. As I mentioned at the beginning, I know I could do this again multiple times, and really want to thank you very much personally and on behalf of IFGT for agreeing to be our guest and to share all of your thoughts, the information. I think you're a shining example of how we are moving away from science and spirituality being two separate things and coming to understand that they are all part of the one interconnected everything. And it's commendable that you've been able to live and bring these two things together in balance, and they didn't make you crazy. And also to have the courage and the boldness to be one of those pioneers in the face of colleagues that probably did challenge some of these things. And I think we all owe you and the others similar in their pioneering. Yvonne Kaysen comes to mind, that we've interviewed a couple of times, that took that chance to be, someone had to be first to say, hey, wait a minute, this isn't just woo-woo, and to bring it into something that can be appreciated as legitimate. But I don't think it's something to take for granted. Someone had to be there first, and yeah, I think you're certainly one of those pioneers. So I thank you for that, and I'm sure everyone would appreciate that as well. I typically, when we have guests on here, they have produced things and have websites and offer services. And so I will ask if you have avenues that, if anybody wants to learn more about your work, are there places that they can go to learn more about you?
Well, actually, you can go to my University of Florida website. You could just Google Erik Deumens. There's only one. And
oh, I think there's an entangled one somewhere else, but we'll another conversation.
and that's where I document some of the scientific work that I'm doing. I don't have any spiritual website, but my physics and the work on quantum mechanics you can find on that website.
Thank you again, everyone, for coming. Erik, especially, thank you for being our guest, and look forward to next time we get to share dinner. So
yeah, thank you for having me.
Yeah, thanks very much.